Good morning, students. Chapter 7, System of Particles and Rotational Motion. Yes, one more question which is again based on principle of moments. See, here it is. A 3-meter long ladder weighing 20 kg leans on a frictionless wall. Its feet rest on the floor 1 meter from the wall as shown in figure. Find the reaction forces of the wall and the floor. What is question actually? See, here it is. It is wall and here it is floor. It is one ladder. Okay, 3 meter long. Ladder is named A, B. It is 3 meter long, means this distance is total 3 meter. Okay, so a 3 meter long ladder weighing 20 kg. Now see, 3 meter long ladder weighing 20 kg means its mass, if it is point D, then it is in downward direction W, weight of ladder. Okay, at point D, weight of ladder in downward direction. W is equal to, yes, its mass is 20 into G, means it is 200 meter, and it is acting at this point. It is acting at this point. Clear about this? Okay. Now, a 3 meter long ladder weighing 20 kg leans on frictionless wall. Its feet, means this one, its feet rest on the floor 1 meter from the wall as shown in figure. So this distance is 1 meter. It is 1. From wall it is at 1 meter. From the wall as shown in figure. You have to find the reaction forces of the wall and the floor. Means at this point what is reaction? At this point what is reaction? See, actually you are given that this wall is frictionless, but this floor having some friction. Why having some friction? Because if this floor is also frictionless, it will easily lay down. Yes, it will easily lay down like this. But see, you are given one word. Its feet rest on the floor. Its feet rest on the floor. Means this floor having some friction. While here on wall, friction is 0. Friction is 0. Do you understand data? Okay. So now we have to find reactions on wall and reaction on floor. So how to find? First of all, on wall, as friction is 0. Friction is 0. Remember, chapter number 5, reaction. Reaction R, it has two components, one parallel to surface, that is friction force, and one perpendicular to surface, that is normal reaction. Yes or no? Yes, it is. Here in case of friction, so friction is 0, means it has only perpendicular component. Okay, and here that reaction is R. It is perpendicular because at this point friction is 0. At this point friction is 0. Okay, so yes, first of all, okay, at point B on wall, as friction is 0, reaction R1 is normal to wall or perpendicular to wall as shown in figure. Clear about it? Okay. So here's first question is you have to find R1. Now similarly at point A on floor. Now it is surface or floor, it is having some friction. Friction means it has two components. One parallel to surface, that is friction, and one perpendicular to surface, that is normal force. So reaction force is like this. It is R2. It is R2, like this, reaction force R2, and having two components, one component parallel to contact surface, that is friction, and one component perpendicular to contact surface, that is normal reaction angle. Clear? Understand now? On wall, as friction is zero, it has only one component, that is, you can say reaction force or normal force. But at this point, as friction is present, it is parallel to contact surface and is perpendicular to contact surface, and here it is R. Clear about this? So in this case, R1 is perpendicular to wall, but here R2 is not perpendicular to wall. Okay? So now, yes, one question: why friction is in this direction towards the wall? Because if this floor is frictionless, this ladder, its impending motion, it is in this direction. Yes or no? Yes, this point A will move in this direction, so it is its impending motion. And yes, we know that friction force is in opposite direction of impending motion. Friction force is in opposite direction of impending motion. So yes, if floor is frictionless, it will move like this. So see, this time can move like this. So friction is in this direction. So yes, it is figure that you have to remember. It is figure that you have to remember. Okay. Now see, at point B, yes. Now at point A, we will write at point A on floor. At point A on floor, as friction is present, reaction R2 is as shown in figure, having two components, N and F, as shown in figure. Clear about this? Having two components, N and F, and you know already about it. Okay, this reaction force having two components, normal force and frictional force. Okay, so are you clear about this figure? Okay, what is in this figure? Okay, now we will write some data. See, here it is. Yes, this ladder is having length 3 meter. Now see, it is 3 meter, it is 1 meter. If it is point C, then according to Pythagoras theorem, how to find this BC? Okay, it is easy. AC square plus BC square is equal to AB square. Yes or no? Yes, it is. Then how to find this BC? So I will write equation AC square plus BC square is equal to, here it is, AB square. Okay, so BC square is equal to AB square minus AC square. So BC square is equal to, AB square. What is AB square? It is 3, 9. So it is 9. B square is 9. AC it is 1. So yes, it is 1. So BC square, here it is 8. Okay, so BC is equal to, what is square root of 8? It is 4 root 2. Sorry, it is 2 root 2. How 2 root 2? Because 8 is equal to, it is 4 into 2. So what is square root of 4? It is 2. And here it is 2. So this distance it is 2 meter. Clear about this? So BC is equal to, it is 2 meter. Now, as its feet rest on the floor, means the ladder and the whole system is in equilibrium. Okay, here the whole system is in equilibrium. Whole system it is in equilibrium. It means, first, it is in linear equilibrium. Linear equilibrium means total force, that is sigma F is equal to 0. Yes, sigma F is equal to 0. Sigma F is equal to 0. Okay, see, in last question, in previous lecture, 4 forces were there. Okay, R1, R2, W1 and W2, but they were only in vertical plane. Okay, but here forces are in vertical plane as well as in horizontal plane. Then I will take two components. Sigma F is equal to 0. First, sigma F is equal to 0 in horizontal plane. In horizontal plane. And then sigma F is equal to 0 in vertical plane. In vertical plane. Let's see, first of all, sigma F is equal to 0 in horizontal plane. Chalo. In horizontal plane, forces acting are R1 and F. See, here it is R1 and F. And see again, from figure it is clear that they are in opposite direction. Yes, they are in opposite direction. So it is easy or it is simple to write. Okay, in horizontal plane, this R1 and F, they are acting and they are in opposite direction. So I can easily write F is equal to R1. Simple. F is equal to R1. Okay, that is equation number 1. Okay, now for vertical plane. Chalo, in vertical plane forces acting are, yes, it is W, and then yes, it is N. This R2 is not horizontal or not vertical. Okay, so yes, it is W and N. And see, they are in opposite direction. So here I can write N is equal to, it is W. And see, W we already know. Where is W? W? Yes, here it is 200 Newton. So here it is 200 Newton. So yes, we have value of N. We have value of N. We have to find value of N. N is equal to, it is 200 Newton. Clear about this? Clear about this? See, we have to find R1 and R2. And to find both R1 and R2, first of all, we have to find F, that is friction force. Now, how to find this friction force? See, we can first condition is used, which is it is in linear equilibrium. Now, which condition we have to use? Obviously, yes, rotational equilibrium. Because as the whole system is in equilibrium, we can write both conditions. We can write both conditions. It is in linear equilibrium as well as in as well as in rotational equilibrium. As well as in rotational equilibrium. Okay. Then how to write? See, here it is. Okay. Okay, now for rotational equilibrium, second, it is in rotational equilibrium. It is in rotational equilibrium. Okay, rotational equilibrium. See, this point rests on floor, means this point is not performing any motion. So here I will take torque with respect to point A. A sigma tau is equal to 0 with respect to point A. With respect to point A, because it rests on the floor. Okay, so about this point we have to take total torque 0. Okay, so to see here from figure some points are valid here. F and N, they are passing from point A itself. Yes, F and N, they are passing from this point A itself. So for this two, torque will be 0. For this two, torque will be 0. Okay? Clear? Whenever line of action of force passes from that point, about that point, torque will be 0. Okay? So yes, F and N, because no perpendicular distance. Okay? So yes, F and N, about that, torque is 0. So remaining forces are only R1 and W. Only R1 and W. Now how to find R1 and W? So see, first of all, here it is. Due to R1, due to R1. Force is R1. What is distance? So it is point A. R1, its line of action is this. So perpendicular distance between A and line of action, it is this distance. Means this two. Yes or no? Yes, it is. Line of action of R1, it is point A. So it is perpendicular distance. And it is this BC, means it is 2 root 2. Means it is 2 root 2. Now torque, so plus sign or negative sign. See, here it is. See, here it is. Okay, again, take a chalk. Okay, this point A is fixed. R1 is acting in this direction, so it will perform which motion? Anti-clockwise. See, like this, R1 is in this direction, it will perform anti-clockwise motion. And anti-clockwise motion, we are getting torque negative. We are getting torque negative. Clear? Now for W, so W, what is perpendicular distance? So it is line of action of W. It is line of action of W. Yes or no? So what is distance of this line of action from A? This distance. Now this total distance is 1 meter. It is exactly at midpoint. So obviously this distance will become 1 by 2. Yes, this distance will become 1 by 2 meter. So yes, it is 1 by 2 meter. Okay, meter 1 by 2. Okay, now again plus or minus. Again it is point A. W is acting in this direction, so it will perform clockwise. It is performing anti-clockwise. It is performing clockwise motion. Okay, so it is taking plus. And is equal to it is 0. Clear about this? Yes, it is easy. Okay, yes, it is easy. Okay, so therefore, I can write, if I take this negative side on opposite side, that is R1 2 root 2 is equal to W by 2. Okay, to make R1 as such, therefore R1 is equal to, it is W upon 4. W upon 4. So now W, where is W? W, it is 200. W is, it is 200 divided by, it is 4. So therefore, how to find R1? 200 divided by 4. 200 divided by 4. Yes, actually it is easy, okay? It is 4 into 5. So it is 50 divided by 2. 50 divided by 2. Or you can also write 15 is 25 into 2 divided by 2. Root 2. 25. 2 means it is root 2 into root 2 divided by root 2. Root 2 root 2 cut. So therefore R1 is equal to, it is 25 into Newton. So it is value of R1. Yes, it is value of R1. Clear about it? Okay, so first answer we got R1 is equal to, it is 25 root 2. Now how to find R2? So see, as R2 having two components, N and F, so we know that, okay, we already know it. Till now R2 is equal to under root N square plus N square plus F square. R2 is equal to, it is under root N square plus F square. But we do not have value of F. We actually have, because R1 is equal to F. So here I can say the F is also equal to 25 root 2. F is also equal to 25 root 2. Clear about it? Okay? Okay. So yes, now we have R2. R2 is equal to, it is under root N square plus F square. What is value of N? It is 200. What is value of F square? What is value of F square? Here it is value of F. So you can easily find what is value of F square. And from this, you have to find what is value of R2. That is reaction force on floor. And second, you have to find angle. Okay, tan alpha is equal to vertical component upon horizontal component. So therefore, alpha is equal to, it is tan inverse N upon F. See, what is reaction of R1? It is easy. It is perpendicular to wall. It is perpendicular to wall. But this R2 is not perpendicular to wall. So what is angle? Yes, what is this angle? So this angle is alpha. And that angle alpha you have to find. The alpha is equal to, it is tan inverse N upon F. Alpha is equal to, this tan inverse N upon. Clear? So again, the method of question is easy. First of all, you have to identify numbers of forces. Then for the system in equilibrium, take first of all linear equilibrium, then rotational equilibrium. Here you have to find numbers of forces. Here you have to find numbers of torque acting on system. Okay, and yes, then it is maths. How to find or how to calculate some quantities. Clear about this? So yes, there is one more question which is based on principle of moments. Clear about this? So yes, it is enough for today. This is it for today.